year, like, oh, Laverne wasn't on, we weren't like Zoom, we didn't Zoom Laverne in, did we? I'm trying to get like a gauge for how many people have any idea what I'm talking about.
I don't remember the presentation last year.
Seriously, Candace?
Shy, I don't think Laverne or Vegas was on that one.
Okay.
Well, I didn't even do it.
That was December of 2019.
Yeah, no, November.
All right, well, some of you might be a teeny bit lost because I really didn't want to repeat information that I've already done, but just stop me if you have any questions, please. This presentation is more of an update for basically since what has happened since the last time I did a presentation on BIPV and what the future holds and what we're looking at here. Exciting, John Santiago joined our BIPV team to help us with design and engineering. And he's actually on this meeting too. So, hi, John.
Hey, what's up, everyone?
So on this presentation, I'm going to kind of go over the UL updates. We're going to take a look at our Horizon and Infinity BIPV Sunshade. We're going to talk about our new Cell Supplier, MicroInversion technology. We're going to talk about Next Energy, where SolarFab is at, and BIPV launch 2021. So I just thought I would start off just to get everybody on the same page with the definition of BIPV. So it stands for Building Integrated Photovoltaics. It's a renewable generating facility which forms an integral and essential part of a permanent building structure, without which non-BIPV building material or component would be required to replace the BIPV. So essentially it is integral to the building structure as opposed to building applied photovoltaics, which would be like solar panels on top of the roof or, you know, on the rain screen or whatever. And this has a lot of benefits, obviously sustainability, and with our current administration, this is going to be a big push for greener buildings and more regulations. So that's good for us and being ready for this new administration. It increases the distributed energy generation potential, and it's capable of serving multiple design intents, visual and functional. And it's also capable of reducing a cooling load through shading. So there's a lot of, you know, we kind of get to kill multiple birds with one stone using BIPV system. And I thought that this was a cool little graphic kind of showing the overlap. So, I mean, you know, it's a laminated outboard light in the IGU. So you get better STC ratings, you get better, you know, thermal ratings, there's shading, and then also, you know, a solar piece of glass can also double as bird safe glass. So there's a lot of good added benefits when using the BIPV system. And I also just wanted to talk about power versus energy, just because this is the language that we use when talking about BIPV. So all solar power output is rated in peak watts, which this is based on the maximum instantaneous output of electricity of any solar panel. And solar energy is output is rated in watt hours or kilowatt hours of electricity produced by a solar panel over a period of time. So just to dive into UL, the last time I gave you guys a presentation, I kind of showed you guys what UL labels that we held and what those meant. Since then, UL has updated their qualifications for their certification. So we went through large area laminate testing again, and we received the UL 61730 label, which is a global standard for PV module safety qualification. And this is internationally recognized, so it gives us the ability to sell our BIPV system all over the world if we choose, which is huge. And then I just wanted to show you guys a couple cool 3D renderings of our two sunshade designs. This is the Horizon sunshade. We have made a couple updates since these 3D renderings, so this outrigger will, not have this notch and it'll look a lot cleaner. But this sunshade is captured both front and back. And then we also have our infinity sunshade, which isn't captured in the front, so it's kind of more of a cantilever design, which is pretty cool.
Nice. Do you have corner conditions for these as well?
Have what?
Do you have corner conditions?
Yeah, I don't have them in this presentation, but we can do corners.
Nice.
This is just kind of a cool diagram that shows how the wiring is inside the, the back part of the sunshade, how it's being ran and how it's connecting to the modules. So I wanted to talk about a new cell supplier that we are trying to get a vendor agreement with. I can't mention what their name is because we signed an NDA, but they are an 18 bus bar cell, which isn't the picture that I have here. But this is actually, I don't know if you guys can see, but this is what the cells look like. Is there a heck of reflection, or can you guys kind of see it?
We can see it a little bit.
So what's really cool about these is that they're bifacial, which means that sun, if it hits the front and then somehow sun gets through and bounces off anything and actually hits the back of the cell, both the front and the back of the cell are power producing, which is why they're called bifacial cells. And they're actually the most efficient cell on the market right now. So they're 20% more efficient than their competitors, which is huge. That really could set us apart. They also come pre-strung. So you lay up solar cells in a row or a column, however you want to call it, but all the bus bars have to be connected on those cells. So they're actually going to sell them to us pre-connected, which is awesome. And their cells produce 7 watts and their competitors are only at 5. So that's really awesome. And then I just wanted to give you guys an update on SolarFab. So in my last presentation, I talked about how GlassFab has another company kind of that they started that they're calling SolarFab, where they have a PV laminating line. So they recently moved that line to their new facility, which brings it closer to the equipment required to turn that PV laminate into an insulated glass unit. And they're ready for production, ready to get some projects on the books, which is awesome. We actually met with them last week and Next Energy to try to coordinate putting a next production line inside SolarFab's facility. So that leads me to Next Energy. In the last presentation that I did, I brought some samples and I showed you guys these little tiny pieces of glass that were totally transparent, but they're solar, photovoltaic. And they did, I did the little flashlight fan test to show you guys. So they've actually gotten up to 14-inch by 20-inch modules now. And a few months ago, we completed a mock-up for them that they sent to a GC in France, which was really cool. Jason and Ray did it, and they built a rolling steel frame, and we used our BIPV W75 system, and they sent it off to France. So there's gonna be a press release about this. I think it got put off because of COVID and everything, but hopefully in the next couple of months, we'll see something on that, which is cool. And like I said, their plan is to try to get a production line at SolarFab, which is huge for us because that means that we'd have really close access to their glass. And that production line is going to produce 5-foot by 10-foot pieces of glass, which is also huge. So they're making the big jump in their technology to ramp up the size. And that has huge implications. Obviously, what is an architect going to do with 14-inch by 20-inch pieces of glass? You just end up with this whole grid system, and them getting up to 5-foot by 10-foot is them being market ready with their product. So I also wanted to touch on MicroInversion technology. So currently we have to electrically engineer a system based off of its power output. And from there we spec the correct line inverter that goes in the electrical room of the building. This inversion is required because the power that comes off of solar glass is direct current. and electricity consumed by the public is alternating current. So everything that the sockets that you plug into the wall, right? With microinversion at the module level, so putting a microinverter on each PV module, there's no longer a need for an inverter and the power can be fed directly into the building. And this is kind of our biggest amazing realization this year for our system, because this simplifies everything incredibly, and it eliminates the need for all of the electrical line diagram engineering that we were having to do before. As well, it frees up space in the electrical room. It just simplifies the whole system. So this is kind of what we're most excited about right now. And we've been talking with a couple different companies about reformatting the shape of their microinverters so that they can fit within our W75 mullions. We've run into a couple roadblocks with that. It's just incredibly expensive, it seems, for them to make this happen. Which leads me to my next point, and that is that we have some upcoming proposals that David Beckham is actually going to write up and submit, and he also joined this meeting, so he's on there. If anybody, David, say hi. You're on mute.
I gotta bring my hand inside the actual, as otherwise it's, oh no, it doesn't disappear. All right, anyway, here I am.
And David's got 5901 Sunset, which was a PV job in Laverne that we did behind him there. But he's gonna write a couple proposals to be submitted to CEDO, which is the Solar Energy Technologies Office, and to BTO, which is the Department of Energy's Building Technologies Office. And this would be grant money to help us with R&D and the costs of this microinversion technology. So it would really help us out a lot, and we could get that going.
Just to add a little extra color to that, Shai, both CEDO and the BTO are have expressed interest in this project to the extent that they're actually willing to grant us money outside of the normal rules of engagement. Normally, you have to wait for what they call FOAs, which are funding opportunity requests by the federal government, and they come, once a year. This is a project that they're willing to set aside the normal protocols and allow us to communicate directly with the DOE. And they both CEDO and the BTO have expressed willingness to match funds with Walters and our microinverter partners in order to fund this thing, which could release as much as $4 or $5 million for the development of this technology, which will be an enormous leap forward. It'll be a world-changing event for sure.
Thank you. Thanks, David. So yeah, as you can tell, we're getting pretty excited because we're starting to get closer to really making things happen, which is our goal for 2021, is to try to launch our BIPV W75 system. Pear Avenue has been released to us by DevCon, so that job went on hold, but it's back online, which we're really excited about. It'll be our biggest BIPV installation yet, and it'll be utilizing our Horizon Sunshade. So this was just some pre-electrical line diagram stuff that we were working on. You can see we have sunshades all over the west and south facades of the building. The ones facing the sun. Just to reiterate how amazing this microinverter technology would be at the module levels, we wouldn't need to do this kind of work anymore. It would eliminate it, which is awesome. I went kind of fast, but it was a lot of information. Does anybody have any questions?
Everybody
Great.
is flabbergasted. It's really impressive.
Yeah, really sharp. No, it was very well done. Let's go.
Yeah, there's a quiz. I hope you guys remembered everything. No, I'm just kidding.
How thick is the glass? Is it like 1 inch just to go into the W75, or are there modifications that we're thinking we're going to need to do for
it's
Pear?
1 1/4 inch or 1 3/16 inches, where it's a nominal. We went with a millimeter. So it's like right in between right in between the two, but we picked the smallest thickness that we could go with and just made that the standard. It's the outboard light is laminated, so getting down to an inch doesn't work when you get to a 5 foot by 10 foot piece of glasses. You'll end up having the glass bowing in the IGU and touching. You need more space.
And then how similar or dissimilar is it in terms of like wiring diagrams to like View and Halio, like running to figure out how to get the power from the solar panel into the building? Like, how's it going through our system?
Yeah, so I kind of really touched more on that in the last presentation, but basically we've designed our W75 system to be basically an electrical raceway for all the wires. So it's capturing everything in all of the, we have an edge mount junction box on the modules, and off of that comes MC4 cables. And then all we have to do is plug and play, basically connect those MC4 cables together in a series. And then there's an end where we have to go up, into the ceiling to tie into the rest of the electrical of the building. But this BIPV system could work really well for View glass and Halio glass.
Cool.
Do we have a list of upcoming jobs that are going to be using this BIPV?
Right now, all that's online is Pear Avenue for the Sunshade, but we get inquiries all the time and are looking at, there was one in Washington that we looked at a while ago, where architect was curious if they could add it to like the spandrel glass on one section of an elevation, but it'll start getting spec'd by architects a lot more, especially after we get some actual installations up and people start to see it. It'll be a really great marketing tool to have it on a real life building and have it actually work.
Right, and we're ready to go live like now. Like we had a.
Nope. Our goal is to totally launch this year.
I know University Plaza 2 mentioned that we're going to redesign to go to an all-electric building. And that's DEF CON, so I'm wondering if they know about this or how we're advertising to our GCs or architects.
Yeah, I think we're being a little bit careful right now just on advertising and trying to put ourselves out there because we're not 100% ready. So right now, we're kind of going off of, well, they want it and we're not going to, miss the opportunity to do it, but we're not out there saying, sell yet for the system, just because we want to make sure that we're 100% ready. I mean, we're introducing such a new technology to the building industry, and a lot of owners and stuff are going to be really skeptical because there's just not a lot of data or, installations of the system. So we really don't want to. Our goal is to not launch too early and not be ready and then do a building and have it be a disaster and lose the trust of everybody for this new item on the market.
Yeah, it's intentional, Oscar. We're just, walk before you run. We're just trying to find, slowly the right job. We ended up doing 5901, learned a lot on that one, which really helped develop where we're at today. We're going to do Pear Avenue. That'll be great. Maybe find another one after that. Just really slowly stick our toe in the water, and every job we get, we're able to just, perform at a super high level.
Knock it out of the park is the plan so that we can build that trust quick.
The customer walks away going, wow, that was great. I want to do that again. So again, it's pretty intentional that we're slowly doing this, not flooding the market with, hey, Walters and Wolf has solar and we're your guy. We want to do every building. It's intentional to go slow here in the beginning.
So Shiloh, once this starts getting into full production, are you long-term, are you looking at possibly stocking the extrusions for these parts and the sunshades, or what's your ultimate goal?
Well, I don't think as a lean company, we don't like to really stock much of anything. So, I mean, I think it'll be just like any other job where we do a metal takeoff and you know, that's how we do it. We haven't had a ton of discussions about, you know, future if, you know, because we kind of designed the sunshades in a way that other curtain wall contractors can take those and put them into their system, or they can retrofit them onto an old system. And our thinking on that is, hey, you know, if the shop is slow with other work, this could be great to have the shop building, you know, sunshades and keep them busy and sell them.
Yeah, it's all building integrated, Heather. So I would think, you know, it's a job by job basis, and whether it's sunshades or going into the curtain wall, we're drawing it with our shop drawings, and it's getting all the metals getting ordered with that job. No different than any other, like a sunshade and normal sunshade on our job.
I was thinking more of what Shiloh was just saying about incorporating into existing projects. It sounds expensive to extrude every single time and long lead times. I mean, I guess it depends upon where the market is.
Yeah,
Well,
and I think if we found a market for that, maybe we'd look at that. But I think that's a ways off before we'd go out selling, you know, this retrofit. Hey, buy these and just bolt them onto your building. That's probably a way.
I'll make sure to get with you once we get there. I'll be happy to get to that point, Heather, that we get to have that conversation and figure out the best way to do it.
Just thinking ahead.
I had a question. So in terms of, I guess, the latest kind of profiles, parts and pieces, should we just go to the Pear Avenue kind of job folder? Is that where we would find it?
That's where you, no, because that, even since then, John's made some updates to the sunshade since those shop drawings have gone in. But Gabe, if you're really interested in looking at what the profiles of that look like, me and you can just set up a little meeting and I'll walk you through.
Yeah, I think that would be nice, because you mentioned that some of these extrusions were kind of designed specifically for the wiring and stuff like that.
Mm-hmm.
That the next generation W75 is kind of not accommodating that. So I just want. So we're gonna keep it like, you know, two different things. Like this is more of a specialty system, and then the next gen is what we're gonna use, I guess, typically.
Exactly. Yes. Yep.
Yeah, I'd be interested in seeing parts.
Yeah, I'll be happy to show you.
What's the, I mean, it's probably too soon, but is the lead time for the glass from GlassFab, is that normal or is it crazy? Like 6 weeks or 10 weeks or 20?
Tom, they were a little late on 5901, right? It took them a bit longer than what they thought it would, but they also ran into a lot of issues.
They had a ton of interlayer problems.
Yeah, so
that's that's not a great example. Yeah, it was a brand new laminating line that they set up, and as well stringers, right? Because they got to string the cells together. They have to lay up the cells, string them, solder them, bus bar, hand lay the cells onto glass with ionomer and then put them through the laminator and then flash test them. But that was all new equipment for them, and they had, they were starting from zero. Like the employees that they chose to work, figuring all that stuff out, they were learning everything from scratch, from the company that they bought all the equipment from. So they had equipment issues, and I think it's a little early to figure out what their lead time is, and I think they're still trying to figure that out as well. But I'm sure they'd like to do a project that isn't the first time they've used the machinery, and see how they can get a flow going and what their lead time really will be. But it's definitely longer than Viracon glass and not as long as View glass.
I think I recall you maybe a year ago or two in a hot summer putting solar cells together. So you're saying that they've come a long way after that?
Yeah. I'm trying to remember, David, we were at the SolarFab facility soldering in like 100-degree weather.
Yep. Yeah. Yeah, that was not fun.
Yeah, but that was because they didn't have the stringer set up yet, or I can't remember why we were doing that.
Yeah, I don't remember either. I've tried to block it.
Block it from your memory. Yeah.
Gotta get rid of that memory.
No, we're SolarFab is definitely trying to automate most of the processes, and then as I said earlier, the new our new cell supplier, the cells will come pre-strung, so no stringing. The stringing machine isn't needed, and there's no human soldering needed.
Yes.
Can you go to your slide? I think it was 3 or 4, Shiloh, that showed the different applications like BIPV and as a glass. You had a whole chart.
Oh,
Just wanted to take a look at that while you're getting other questions. So is there, I guess, a preferred application that yields the most power, the most benefit?
spandrel glass, I think, is going to be our big one. You know, there's so much square footage on the building. You can get the solar cells all really close together and packed in there in the area. And you know, the architect isn't concerned about needing to see out of spandrel glass, so that helps a lot. I think spandrel glass is kind of a no-brainer for this system. If you're not going to incorporate it, I mean, we've even looked into some products called chromatics, which, and I think David could probably speak on it a little bit more intelligently than me, but it's some type of film on the outboard light that would basically hide all the solar cells, but it still lets all the UV and the sun rays through, so that the cells are still producing power, but it just completely covers it, so you wouldn't even know that it's solar. It would just look like a blue spandrel or a green spandrel.
And they have
Have you done
IC
any-
flooring. Do they have?
Say that again.
IC flooring as well. Is that an option? Make like a balcony with glass or something?
That's definitely not anything that we're looking at. So
Okay.
Yeah, there are some specialty applications where you have glass blocks that can be incorporated into public walking areas and these types of things, where the actual the walking surface itself has solar cells embedded in it. That's a very niche application. I wouldn't be looking for too much of that, but it is out there. It is a technology that is available.
Thank you.
Can I just make one comment, just to add something to what you were saying there, Shai, about there might have been 2 questions in there. Spandrel will definitely be the highest coverage area and the most cost effective. That one is just low hanging fruit all the way. But the power yield, the actual yield per square foot of energy, is definitely going to go to the sunshades, which is part of the reason why we're trying to package this up and push it forward, because it's a much more specific application, and because the actual solar unit itself is going to be, the angle of the actual unit is going to be set to whatever the solar angle is at the latitude where it's installed. It's going to operate much more like a standard solar panel. So it will have a higher yield. You'll get more power per square foot out of it, but you'll have less square feet of it. So depending on this question kind of sounded like what was the most efficient or the highest yield, that would be the solar sunshade, but the spandrel glass will definitely be the most bang for the buck. That's definitely for sure.
Got it. Okay, thank you.
Is there any acoustic testing or STC values or benefits to using this product also?
Yeah, we haven't done any STC testing, but it would absolutely, we should get that on there, because I think it would have a very high STC rating with a laminated outboard light, which is pretty much what they do for STC class, right?
Yeah.
It would probably be very similar to an SGP, to a Sentry glass. It has a similar ionomer interlayer, and you're talking also about a similar glass thickness as well. You're probably talking about a 3/16 or a 1/4 inch glass with a couple of mils of ionomer in between, which I mean, it'll basically the SDC characteristics will be very similar to SGP.
Cool, thank you.
Well, you guys didn't have any questions in the first second, and you guys have just been firing off. Cool. Well, if you guys think of anything or you want to chat about it, I'm excited. So I love to talk about it. So hit me up. David could talk your ear off as well if you want to go that route. But
And for anybody, if this stuff comes up on your jobs, you know, go to Shy and start there. I don't want us starting to, you know, go into the Pear Avenue file and pull some details and go talk to somebody about it. You know, anything comes up, send it through Shiloh. Just because we need it very controlled here in the beginning, and we want to make sure we're giving the customer the right information. So I don't want people running off going, sitting down with a GC or an architect going, hey, look what we're doing.
Yeah, let me add something else to that, Tom, just on a comment that someone made earlier about you know what we were prepared for. If somebody came to us with a solar job today, we could do it. But what we've learned, I think, over the last number of years is that we really needed a new methodology altogether, something that was going to solve all these complexities on the front end and the back end of the job. And that's what we've been working on for the last year and a half now, to create a standalone unit that will be much easier to spec, much easier to install, much easier to engineer, takes all of the complexity out of it, but that's not ready. So we, like I say, we could go to the market. If somebody came and said, bring us, you know, we want BIPV on this job, we could do it. But the reality is this new technology, this is going to be, you know, this is going to be a number of months yet in development, but it truly is a quantum leap. We're going to a place where once we introduce this into the market, anybody else in the market that's offering BIPV will be obsolete overnight. We will have a technology that if you want to be in this market space, you will have to do something similar to what we're doing, because it's just simply the most elegant way of solving building integrated photovoltaics that has been presented to the marketplace to date. So it's a reason for everybody to be very proud of this. This is going to put Walters & Wolff in a very different space in terms of sustainability and renewable energy. We will have the pole position and the lead for some time. It'll take a while for our competitors to catch up with this. It's that big of a leap.
he's a sales guy. Can you guys tell?
And I'm not a sales guy. I'm the sales guy. Thank you very much. Also the David Beckham. So let's get that straight.
All right, guys. Well, thank you for taking the time to listen to all of this.
Thank you.